Awesome. Welcome to Road to Web3 Week 7, right? Road to Web3 is a program by Alchemy where we are trying to foster a community of devs who like to learn and code together. Uh, it's been the past 6 weeks, I think, have been super exciting, where we've taught a lot of our devs a ton of things about how to build smart contracts, how to make your front ends interact with smart contracts, and how do you build end-to-end applications using the blockchain. Uh, and this week, with week 7, we're taking it to the next level. We're doing something a little bit more complex, but a lot more fun. Uh, and before we dive deep into that, it's important that we talk about Alchemy. Alchemy is the de facto platform for Web3 development, and we have a ton of services that make developers' lives easier. To start with, we are a node service provider, which means if you build literally anything on Web3, you'd probably be using an API endpoint for us, and it's kind of like using AWS for building in the Web 2. We have other things like enhanced APIs. So if you're building NFTs and you want to pull NFT data from the blockchain, we have the NFT API. If you want to pull data for a certain token like ETH, we have the token APIs. And then we have many more APIs that will help you along your journey. With Road to Web3, we're putting in sufficient resources and effort into growing the Web3 community, the developer community, and helping devs learn about Web3 programming in a much easier fashion. All right. So without wasting much more time, let's deep dive into how do you build an NFT marketplace, which is the topic for this week. Sweet. So before we do that, hi everyone. This is Aniket Gupta. I am a developer advocate at Alchemy. Before being at Alchemy, I was an entrepreneur. I started a company in entertainment, also another one in Web3. And that's when I got to know about Alchemy. It's awesome. It's an amazing platform, and it is going to change the world, right? So if you're a Web3 enthusiast looking to talk to me, or any developer literally anywhere around the world, especially India, feel free to reach out to me at ankg404 on Twitter, and I'd be super happy and I'd love to have a talk. So before we go into building and actual coding, let's start out by talking about what is an NFT marketplace, right? So I'm sure you've heard a ton about NFTs generally, right? Huge volumes taking over the world. NFTs very briefly is like owning an item on the blockchain, right? So you can, I mean, it empowers you to put on audios, videos, um, images on the blockchain and own them. And what's special about them is that they're rare. They're like one of ones or super unique. It's kind of like owning the Mona Lisa in the real world, right? And we all know how important that is to so many people and how costly that could get to several hundred millions of dollars, right? So all of these NFTs, popular projects like Bored Ape Yacht Club, Axie Infinity, CryptoKitties have been taking over the world for a few years or a few months now, and I'm sure that you've heard of its impact. Now, getting deeper into it, right? What is an NFT marketplace? So, as these NFTs became more common, and there started to be a lot of use cases for these NFTs, that's when people felt a need to connect the buyers and sellers of these NFTs, right? Uh, Before that, it was mostly over the counter, and then people were finding out the owners of those NFTs and buying it. But then there arose a need, since there was huge volumes, there arose a need that buyers and sellers come together on a platform and exchange NFTs with each other, right? So we make it super, like these NFT marketplaces make it super easy for buyers and sellers to connect, find the right price at which they can transact, and then proceed with the transaction, execute it. It makes it super simple, right? So, in short, I think this is a very apt definition of an NFT marketplace. It's basically a marketplace or like a market that connects the buyers and sellers of an NFT, right? This marketplace helps people find a price and then provides utilities for smooth transactions, right? Ultimately, this marketplace helps grow the pie for the entire NFT market. So, going deeper into it, right? What is going to be the structure of this NFT marketplace from a developer standpoint? We're going to have a front end, which is like a website where all of those NFTs will be listed, where a normal user might be able to go list their NFT, and then people can go buy the NFT, right? There'll be a smart contract, which is actually the layer that interacts with the blockchain, right? Any NFT that is uploaded will be uploaded to the blockchain with the help of functions that are written in this smart contract. This is the piece of code which is actually crucial with our platform, our application, our DApp, decentralized app, interacting with the blockchain. And then another third very important part of this tutorial will be the decentralized data storage that we use, right? Um, Basically IPFS, if you've heard of it. If you haven't, I'd recommend go read about it. But it's basically a decentralized data store where we'll be uploading the NFT metadata, basically data about our NFTs, including the image itself, the name of the NFT, the description, and all of those other details, right? And I'll come to later why that's actually important and why do we even need a decentralized data store, right? Prerequisites. To do this tutorial, you don't need a bunch, honestly, and you can learn on the go because I'll be talking about a lot of that stuff. Um, React.js will be used to build our front end during this application. For the purposes of this application, the front end is mostly built, right? It's a complex one, right? I wouldn't say it's a very easy one to build. It'll still take you the weekend, which is why we encapsulated away the complexity of building the front end. And what we'll be talking most about is the backend, which is the smart contract, the IPFS, and all of those interactions, right? So then the first, I think, prerequisite to understand this becomes React.js, through which the front end is built. Then we have Tailwind CSS, which is an awesome tool to write down CSS without writing down a ton of properties. Like you can just plug in classes and then the object, like the HTML object, is styled by itself. And that is awesome. And then the third and the most important prerequisite is actually having a passion for Web3, right? I think if you have a passion for Web3, you'll probably ace every other prerequisite right away. So what do you need to do to develop an NFT marketplace, right? Basically, a couple of things. We'll be using Solidity, so the smart contract backend that is written, which actually interacts with the blockchain, is in Solidity. The blockchain that we'll be using for these and the building the purposes in this tutorial is the Goerli testnet. Sorry. So basically, the testnet that is on Ethereum. It's one of the most popular testnets now. So just a short note that Rinkeby used to be one of the more popular testnets earlier, but with the ETH merge incoming, Goerli is becoming the more popular one. So you'll keep seeing more support for Goerli, easier to get more ETH on the Goerli testnet and do all sorts of things, right? Which is why we recommend that you use Goerli for this project, even though you're free to go use any other testnet as well. The second thing that you'd need is a node service provider like Alchemy. So every time you go ahead and deploy your smart contract, right, to interact, you're interacting with the blockchain. Or you're going to upload an NFT in which, like, you upload an NFT, you upload an image, you write out this details, you submit a price, and then you hit submit. When you do that, again, you're interacting with the blockchain. So every such time, when you're interacting with the blockchain, you need a node service provider like Alchemy. And I'll show you how to set it up in your repository, in your Metamask, which is the wallet that we'll use for development. But Alchemy is the service that you have to use. And if you haven't done it yet, just go ahead to alchemy.com and create an account, sign up on the platform. The third thing that we'll need is IPFS, right? So IPFS, like I mentioned earlier, is a decentralized storage. We'll specifically be using this service called Pinata, which Pinata is a very easy to use IPFS front facing platform where we have a really nice interface to interact with IPFS, right? And IPFS is a decentralized data storage. Why is it important? Because if you wanted to develop an NFT marketplace, right, you have all of this data that needs to be stored. There are NFTs, the images that need to be stored. There's metadata about those images that need to be stored. And all of this data, if you store it on the blockchain, actually, right, if you're putting it on Ethereum mainnet, it's going to cost you a lot, right? So it's going to cost you a lot. It'll also be expensive to fetch data every time in terms of time as well, which is why we tend to use IPFS. So the idea is that all of your metadata of your NFT, right, the image, the name, the description, everything is pushed onto IPFS. So it's outside the Ethereum blockchain. And then it returns you a URL, right? So you have an IPFS URL, which maps to all of your metadata. Now that IPFS URL is all we save on the blockchain, right? So it's like having all of the data elsewhere, but also keeping a mapping of that data with a smart contract on the blockchain. Another thing that you'll need is a developer wallet like Metamask. So if you do not have Metamask installed, I just recommend go to the Metamask website, try to set it up on your system, and we'll also need to load it with testnet Ethereum to be able to run our transactions, to be able to deploy our smart contracts, right? Um, and the testnet, like I said, the one that we recommended is the Go Early testnet. And the last thing that we'll need is a front end website, right? So all of this, like we said, right? There's Solidity, which is a smart contract. There's a node service, which is Alchemy. You're using IPFS to actually store all of that data for NFTs, and you're using MetaMask to actually, pay for everything that you do on the blockchain. And then to do all of this, to support all of this in the front end, you need a website, right? Like a platform which is easy to use, has clean UI, clean UX, and people know what to do when they look at that website, right? So, like, you can go log in with your wallet, actually go out, upload an NFT, view those NFTs on the marketplace, and if you need to, and if you want to, go buy somebody else's NFT. Sweet. So I think that is all that you'll need. I mean, there's tons of context here. If there's any question, just feel free to ask us on our Telegram channels or our Discord channels for O2F3. We'll be happy to talk to you, happy to support you. But we're going to get into each of these nuances throughout this tutorial. This is an NFT marketplace, for example. This is a screenshot of OpenSea, which is one of the biggest NFT marketplaces, also one of the biggest NFT companies. They're great partners to us. So shout out to OpenSea, who's been using Alchemy and has been one of our biggest customers. So in this page, as you see, right, there's like a wallet login on the top right. So you can go log in with your wallet, actually be able to view your NFTs. And then there's this listing page, right, where you see all of these beautiful NFTs being listed from the Autoglyphs project, for example. You see a price, the price at which they can be bought, an image of that NFT, and just a general listing so that you're able to view them, right? Like if we clicked on it, it would have opened this NFT and we could have gone and bought it, right? So this is like similar to what we'll build. Obviously, OpenSea is a $15-20 billion company, and we're not going to build an OpenSea replica in this tutorial because that'd be too much for you. But we're definitely going to build some really important and really cool features from OpenSea, enough to support an NFT marketplace. Sweet. So this week, week 7, what are you going to learn? You will learn what is an NFT marketplace, what is it that you need to do to be actually able to build one. Um, Writing the smart contract of an NFT marketplace, I think that's one of the biggest learnings that you're going to have from this tutorial. The next one would be, how do you upload NFTs to IPFS, right? So basically, when you have the smart contract, you have the front end, and you upload an NFT, that NFT goes and stores itself on the IPFS. How does that happen with APIs? How does that actually come through? That's going to be fun. How do you use Alchemy for all of your marketplace, and how do you actually like empower your marketplace by using Alchemy? You'll also learn how to deploy on the blockchain, which I think we've covered in the previous tutorials as well, but I think that's a plus here. And then you'll definitely learn how to integrate your smart contracts with a complex front end, right? Because a product like this, like the marketplace, needs ton of integrations. Like every single page will either be writing to the blockchain or reading from the blockchain, and that has to be integrated with a smart contract so we can see how that is done, right? Also, small shout out that every week as you complete challenges, you get these awesome NFTs, right? And that is the biggest bragging right that you have over here. If you join the Road to Web3 program, if you're on our Discord, if you're on our Telegram, and you're completing these challenges, as you complete them, it's so awesome that you get these really cool NFTs from Mint Kudos that you can show off, right? So if you haven't already, just make sure that you're on our Telegram. Which is link is in the comments in YouTube, and you'll also find it in on a lot of our other channels, right? So go to our Discord, go to our Telegram, and make sure that you're connected to the rest of the community because there's a lot of stuff happening. Great. Couple of things about Alchemy. Alchemy has tons of products, like I said, and is one of the best performing node service providers. So if you're pulling data from us, we have a data accuracy of above 99%. We have an uptime of above 99%. And then a lot of biggest Web3 companies actually trust us with their services and use our services to power their products, right? And then as you come use us, we'll probably be providing you the best customer support across any node service provider. Couple of things about a product suite very quickly. So like this is a screenshot from our website. If you go to alchemy.com, you should be able to see all of these things. Very quickly, we have this super node, which is the product that powers all of our node services, right? So when you're using our nodes, we have this really robust infrastructure of nodes that makes it super easy and super convenient and super reliable for people to be using and interacting with the blockchain, right? We have a ton of tools for prototyping and debugging. The very good thing is that while you interact with blockchain using our contracts, our platform and our products, you'll be able to monitor and analyze all of your performance, right? So how many requests were hitting, which were the requests that were failing, what kind of users do you have, a lot of those things. And that is going to be super helpful when you actually turn out to grow your product, right? We also have this amazing API called the Notify API, which kind of helps you set up notifications of the blockchain, right? It's been an archaic problem to receive notifications from the blockchain, and we solve that with the Notify API. We have enhanced APIs which actually help you use the blockchain in a much more cleaner, more convenient way, and then tons of other stuff, right? We're on all of these blockchains. We're on Ethereum, Crypto.org, Flow, Arbitrum, Optimism, Polygon, Starknet, and one of the newest additions to our stack, the Solana blockchain, right? So if you're building on Solana, I think this is time that you make an Alchemy account, go ahead and start using our service. Awesome. With that, I think that covers our initial presentation. So that should have given you some context on what we are building, why we are building it, and how we are going to build it, right? And then to add a little bit more context, let's do a small demo of the final product so that you know what we're going to build. Sweet. Great. Thank you for sticking in so far. Now we're going to just chat about the product itself. Just show you a very quick demo so that you have in your mind what exactly it is that you're building, right? Um, when you land on the marketplace, this is what it looks like. This is the marketplace page where you'll be able to see all of the NFTs that are listed. This is the list my NFT page where you can actually upload your NFTs, put in a name, put in a description, put in a price, upload an image, and actually go out and list your NFT, right? And this is the profile page where you'll see data about the NFTs that you own, that you are trying to sell on the marketplace or that you've bought, right? Um, and then there's this connect wallet button, which basically lets you actually connect to the marketplace using your wallet, right? So to begin with, we do not have, like, we're on MetaMask right now. So if you haven't already installed it, head over to MetaMask's website and install the MetaMask extension. The network that we want to actually run this website on is the Goerli testnet. So make sure that you have certain testnet ETH on the Goerli network. And what I mean by that is that you have to go request it from the faucet. I'll talk about it in a while. But essentially, something super quick, when we actually start to build this application, um, you'll just see that a lot of these things are slightly complex to understand and slightly complex to build and come with slight challenges since it's Web3. But you're definitely going to love the way you learn it. Awesome. So as you land on the website, the first thing that we should do is try to connect our wallet with it, right? So if you click on connect wallet, it will first request you to switch the network. So if your MetaMask wallet is on a network that's different from Goerli, it'll probably first ask you to switch it. Hit switch network. It then asks you which specific account do you want to connect to run the platform for the marketplace. So I just selected my first account and I hit next and connect. And as you can see, it's now connected, right? So basically, it's connected. It says that it's connected to this particular address. And for the purposes of this tutorial, because we all love dogs, I personally love dogs, and I think Alchemy loves it a lot as well. And I'm sure a lot of you learning from this video also do. So this is basically a dog NFT marketplace where we've uploaded images of dogs, really cute dogs that you can go actually buy, trade, upload, all of that, right? So the current address that I'm logged in with is able to view these NFTs. If you go to the profile section, you'll be able to see that, okay, these are the three NFTs that this current address has uploaded. This is the wallet address. These are the number of NFTs that are on this marketplace, owned by me for this wallet address, and then the total value of that in ETH, right? If you wanted to test out actually uploaded NFT, so let me quickly show that flow to you. We can upload like a photo of another dog. Um, QDog, just set the price to, I don't know, 0.02 ETH and try to choose an image. So I have another QDog image right now with me, and that's this one. Sweet. We uploaded, and then we hit list NFT, right? What happens is that before, so that you can list it, at this point, you will have to pay a price to be able to actually list it, which is the estimated gas fee. It is this much, which is a pretty small amount, but you definitely have to pay every time you interact with the blockchain, right? I'll just show you after doing this, how can you request it from the Query Faucet. Awesome. So like it says, please wait uploading up to 5 minutes because it takes a while to upload anything to the blockchain, especially the test nets because they run a little slow. Yeah. And as it gets done, we'll probably see a message popping up talking about that. Meanwhile, while we wait for that, you can go to gorleyfaucet.com where you can actually request Gorley ETH, which lets you be able to develop using blockchain, using Gorley testnet, and also upload NFTs, for example. Now, if I wanted to request this for my address, I'll just copy in this address, paste it over here, and request them to send me ETH, right? And it says, okay, the ETH was sent to me. This is a cool animation. And then I should receive it in some time. So if you probably refresh it in a while, you'll be able to see that we actually have Gorley ETH in our wallet. Back to our React app. Oh, so it actually uploaded the NFT and redirected us to the marketplace. So you can see that our dog number 4 is now here, and now we have another dog photo uploaded to the marketplace, right? Now, and it'll also show up in your profile page because this is the 4th NFT that you've actually uploaded. If we switch address, by the way, we'll be able to see that okay, our profile NFTs change, and there are NFTs that we do not own, right? Like if I click on this NFT, for example, it says okay, you are the owner of this NFT, and all of the other metadata about the NFT. If I switch the address, which is account 2, I click on connect. You'll actually see that instead of you are the owner of this NFT, it shows me the option to buy this NFT, right? Now I can click on it and go ahead and buy this NFT, and the NFT will be transferred to this second address from the first address. And if I go to profile, you see that the profile is empty because none of the NFTs on this marketplace are currently owned by the second address. Awesome. So I think that's a demo of the marketplace. I hope you have a good understanding of what the marketplace looks like and what is it that we're going to build. Awesome. I'm pretty happy that you've made it so far, and now you understand what an NFT marketplace looks like. You also understand what it's going to take to build this NFT marketplace, and you definitely know what does the NFT marketplace that we're building exactly look like, right? At this point, we have to start jumping into coding, and we'll write down some code. The first thing that we'll do is clone the GitHub repository. So we have a bare bones structure already. Basically, the front end is already programmed, and it's here in this GitHub repository. So it gives you a starting pad basically on top of which you can start to build the project. If you want, you can go ahead and build the front end by yourself, though we recommend that you first complete this tutorial and then you can go ahead and try to do the front end, right? It's this URL. The URL is also in the description of the YouTube video. So I'll just go ahead and clone this into my local system. So the command would be git clone, and yep, that clones it. It was pretty quick. You can cd into the project, right? So as you can see, there's a lot of things are already set up. The bare bones structure is set up, the folders are set up, and you'll be able to broadly see that, okay, all we have to do is just install the relevant packages and go ahead and start programming, right? The first thing that we do is do an npm install. The point of doing an npm install is that there are tons of packages already in the project that have been installed, that have been configured, but all we need to do is install them for our local system, right? If you go into your package.json, you'll be able to see that, oh, these are all the packages that we are using in this project to build it out, right? Basically, Open Zeppelin contracts, which is used for our NFT marketplace specifically. Where basically in this NFT smart contract, we'll be using smart contracts from Open Zeppelin to actually make them work. We have certain testing libraries. We're using Axios. So when we fetch data from IPFS, we do it by using Axios. And then there's a couple of React projects that we'll be using, right? So not a lot of packages, but there are some. Other things that we're using are Hardhat, for example, right, which is pretty critical to our development process because we'll be deploying using Hardhat. If you do not know what Hardhat is, I recommend go to check out their website. It's a supremely helpful uh, developer tool, and any developer developing in Web3 should have it in their toolkit, in my opinion, right? Um, what else? So I think we also have Tailwind, which is a super important part of this project. It's like when we install Tailwind, we basically put in this config, and you can go to Tailwind's website to see what is the right way to install it. But yeah, the idea is that we have the main packages are Tailwind, Hardhat, OpenZeppelin slash contracts, React.js packages, and these are the packages that we're going to build into. Now, you do not have to worry about them. The point here was just to tell you what those packages are, but they're already configured in this repo, so you do not need to worry about them. Awesome. It seems like the dependencies and the packages are already installed, and now it's time to go load the marketplace and see if it's working in a system. Sweet. Now, if we go to localhost, so it started in 3001. For you, it probably started on the port 3000. You'll be able to see that the NFT marketplace works, right? Sweet. Basically, nothing will work right now because the code that we are using does not have any integrations with the smart contract or the smart contract itself. But what you'll see is that you have a clear looking front end where you can sort of navigate and see things, right? But do not expect anything to work. Do not click around because it's probably not going to work and it might even error out, right? Now you have this setup. You have this app running in your local host, and then now the next step would be to start coding the smart contracts, right? The smart contract will live in this folder, right? So contracts NFT marketplace dot sol, where we only have just one line telling the version of the Solidity. But next steps, let's go get get to the smart contract and start coding out some Solidity code. Great. Now that you have set up the repository, it all works for you, and we just want to start coding right away. The first thing that we'll be doing is migrate to the NFT marketplace.sol file inside your contracts folder, right? You already have one line there which tells you about the version of Solidity that we are going to code in, but we have to write down the next, right? So to start with, I'll be importing a couple of classes slash interfaces that will help us with the implementation of the smart contract, right? Um, just to make no spelling mistakes, I just wanted to copy it over. And so I'll probably explain these. However, like Hardhat console.sol is the console.log equivalent in Solidity, which means this particular interface exposes some functions that you can use to for logging, and then it will help you debug your smart contract, right? Then a couple of other imports that we have over here is like counters.sol. This is a pretty interesting one. So you'll keep seeing as you implement smart contracts, you will keep seeing the counters.sol keep coming up again and again. What it is it's a safe and secure implementation of a counter in Solidity, right? So if you want to have, let's say, you want to track the number of items sold in your NFT marketplace, this is a number, and this is incremented by one every time. So this is basically a counter, like a very good fit for a counter, right? So any such counters that you have in your smart contract, you should use the counters.sol extension, the data type that it provides, and I'll show you how to use that, right? Other imports are the ERC721.sol, which is the Open Zeppelin implementation of the ERC721 standard. Whenever you're doing an NFT project, could be a marketplace, could be a 10K, NFT PFP project, profile picture project, or any other NFT minting project, you would probably be using the ERC721.sol contract from Open Zeppelin because it's one of the most widely accepted and standard implementations of this, right? Makes it super easy for you to actually develop on NFTs, on the NFT infrastructure, and makes it quick, makes it secure. So there is no reason not to use this. Another import that you'll see is the ERC721 URI storage. This is just a set of functions, and it's an interface basically that exposes some functions which help you with storing the token URI, right? What is a token URI again? Token URI is the URL where the metadata of your NFT will be stored, right? So it'll be something like ipfs.io/ipfs slash a whole hash. That particular link is where like you're going to store token metadata for every NFT, and the functions in this particular interface will help you retrieve, manage, maintain that token URI. Right? Feel free to go to these websites, OpenZeppelin's utilities where they've talked about counters, OpenZeppelin's ERC721 where they've talked about the ERC721 standard, and the ERC721 URI storage where basically you can see the functions that it implements, right? OpenZeppelin documentation is great and it will help you understand whatever code is there in these interfaces slash smart contracts and will help you make better choices whenever you're writing code. And then this is the Hardhat console.sol page where you can go read more about it. Awesome. Let's start out by writing the contract now. So it will start with something like this, starts with the contract keyword to tell Solidity that you're actually writing a contract. We will be extending the ERC721 URI storage interface here because we're going to be using functions from that in addition to the functions from ERC721, right? The first thing to define here would be a constructor, right? Each of these, which is why you were seeing the red line over there, that the Solidity smart contracts demand a constructor right way. And it goes something like this. So basically, we'll be using the constructor of ERC721. You pass in two parameters to this. One is the name of the class, and then the acronym that you want to see it with, right? This acronym keeps coming up whenever you're deploying the smart contracts. One thing that we do as a constructor is created is try to store the owner of the NFT marketplace, right? Why that is important is because the marketplace has the listing fee, right? So any user, when they come on the marketplace, actually list down their NFTs, they will have to pay a small fee, which is the marketplace fee, right? So that's the fee that like nobody gets except the owner of the marketplace, the person who owns and who has deployed the marketplace. Could be a person, could be a smart contract or address, whatever, right? But in this case, when we try to save the owner, it is the person, is the smart contract address that has deployed this particular contract. And the way we write it is owner equals to payable message dot sender, right? Payable keyword basically makes that particular address payable, and by payable I mean this address is eligible to receive ether from the smart contract, right? So whenever an address is defined as payable, then it is eligible to receive some ether. If you do not define it, Solidity will error out when you try to send any ether to that particular address. Awesome. It errored out on owner, so we'll basically define the owner variable, and it has to be payable because we want to be able to pay it at some point, right? What are the other variables, right? Let's basically define the other variables. So we'll first use the counters dot sol, right? So basically, what we're trying to do is get the counters implementation from the counters.sol contract because we are going to use this as the data type that is exposed from counters.sol, right? We'll use this as the data type to define a couple of variables over here. Those would be, the first one would be, and it's also the most important one, by the way, it's one thing that you'll keep seeing throughout your smart contract. It is a token ID, right? So basically, this is the current maximum token ID that's going on, and these are like one. So the first NFT minted is like 1, second NFT minted is like 2, third NFT minted is like 3, and it keeps on incrementing like that. Another thing that we would want to store is the items sold on the marketplace, right? Like this is something that we should store now because it's like a generally helpful variable. We can fetch that, we can make decisions on basis of that, we can do a lot of things. And then one last variable, so these are the two counters that we're going to use. And then one last variable that I also want to track here is the list price of the marketplace, right? So remember, like I told you, there's a listing fee on this marketplace. So whenever somebody wants to list out their NFTs, they will actually have to pay this particular list price, right? So in addition to whatever gas fee they pay, they're also giving this away because like that's the fee that the marketplace demands, right? It's awesome. Note that you can write the keyword ether in Solidity with all convenience because it's a special keyword in Sol and it interprets it as actually ether, right? I mean, if you wrote it as way or gwei, then it would have been totally different interpretation of this number. Awesome. Cool. A couple of other variables that we wanted to implement in the beginning before we start to write out the functions is a struct that stores the listed token of the smart contract. What is a listed token, right? So when the NFT is created for the first time, it is put on the marketplace with certain parameters, right? Those parameters have to store the data of that particular NFT, right? What are the parameters for an NFT, right? It is the token ID of that NFT, which is one of the most important parameters. The owner of that NFT, who is the person who actually created that NFT in the beginning, the seller of that NFT, the person who's currently selling that NFT on the marketplace, right? The price of that NFT. So the price that has been set by the current seller. The current seller, when they actually listed on the marketplace, decide a price, right? Like the form that we saw on the website where we were just choosing the price for the NFT. That is where they decide a price for the NFT. And then currently listed is just a Boolean variable, which like something to detect that, okay, this NFT is currently listed on the marketplace or not listed on the marketplace. So we'll just put them down. So the token ID is one, address payable owner is one, address payable the sender of the seller of the smart contract, the NFT. You have uint 256 price, um, and then a variable to see if the NFT is currently listed or not. Um, I think you probably understand most stuff here. I've also talked about payable. UN 256 is just an int type in Solidity that can store bigger numbers, right? There's uint 8 as well, uint 16 as well, and likewise. And the struct is basically the structure in which it will be stored. So we'll be using with this struct basically later to retrieve information about that NFT. This structure will be mapped to the token ID of that particular token. So token ID mapped to all of the data of the token, and that will be very helpful when you want to fetch or sell, be able to sell or transfer NFTs. Awesome. And then we'll use one last thing, which is actually maybe not. We can skip that one for now just to keep things simple. But yeah, this one last thing, basically, so you have a token ID, right? Every time you mint an NFT, you have a token ID that's incrementing. You have all of the data about that token in this particular struct that we just talked about, right? Now, you have to maintain a reverse mapping between the two so that when you retrieve a token ID, you're able to retrieve all of the data for that token ID, right? So we're going to create a mapping that that maps a token ID, a number, to all of the metadata of that token, right? So that mapping will look something like this. Mapping uint 256 listed token. Awesome. Okay. So this is the mapping where we are going to map a token ID, which is of type uint 256, to values of type listed token, which is this struct. Sweet. I think that is it. That these are the variables that we're going to declare. We're also going to declare a couple of helper functions, right? Before we get to the main functions of being able to create an NFT, buy an NFT, sell an NFT, those things, we want to first just write down some certain helper functions that will help us test and retrieve from the smart contract. So some of those are like this. So if let's say the owner wanted to update the list price of the marketplace, so kind of like uint 56 list price. So basically, this function lets an owner later modify the list price of their marketplace, right? If they wanted to change, okay, my marketplace is popular now. I've been charging 0.01 ETH, but now it's time to charge 0.05 ETH. They can call this function and update the price, right? As you probably know, Solidity smart contracts cannot be edited. So the first time you're actually deploying it, it makes total sense to basically write down these functions right now because you cannot add these functions later. Right. So the first thing that we should check is that this function should only be callable by the owner of the smart contract and nobody else. Right. So we check owner equal to message dot sender. If this is not true, then you display this message, only owner can listing price. Awesome. What is this error? Comment out the variable name. Oh, okay. That's because we haven't really used that value right now, but we're going to use it now. So basically, we do list pricing, right? So basically, if the owner is not equal to message.sender, you have to throw an error with this description, and if it is actually equal, then it will proceed to this next line where it will update the list price of that marketplace. Awesome. Let's quickly get to the next function. Um, function get the list price. This is important because when we'll actually be sending transactions, we should know this value, right? And since it's stored in the smart contract, we will have to fetch it in our front end every time we try to list an NFT. This will just normally return the list price. Awesome. I hope this makes sense so far. If you have any doubts, questions, feel free to reach out on our Discord. We're always happy to answer. Like, we have an amazing team of DevRels here, and we're always happy to help you guys. Awesome. Another one would be get latest ID to listed token, right? Which where it's just a fetch function for retrieving info, and this will be helpful whenever you're trying to test it, right? Something to talk about here. It's a public function, which means it can be called outside the smart contract. Basically, if it was a private function, then you could have only called it within the smart contract itself. But because it's a public function, we can send a request from the front end to call this function directly. When we say the view keyword, it's important because we're not making any edits here, right? We're not writing to the smart contract. All we're doing is fetching from the smart contract, right? So it's just a view function. It's not necessarily an update function. And Solidity demands that you kind of define this whenever you're doing something, okay? And yeah, it returns a UID56. Likewise, same for these keywords over here. And listed token here is the type that we actually talked about, right? The type that we've created here, that same type. And then memory. So basically, there's two keywords in Solidity, memory and storage. It's just an instructional keyword here that tells Solidity whether to create a temporary memory allocation for a variable or a permanent allocation, right? So when we when we actually write down the storage keyword, let's say we wrote storage here instead of memory, then it would have created a more permanent location for that variable. It's more costly, and probably adds to the time of execution as well, but costly is the biggest parameter. If you add memory, then it's not as costly, and it's just memory created for this function. It's not actually taking up space in the blockchain. Sweet. So we basically here will return ID to listed token. Return the token ID, right? Listed. Yes. So we first want to fetch the latest token ID, right? So the current token ID is equals to and then we do current token ID. Oh, sorry, we have a spelling mistake here, which is why it's been read the whole time. Great. So essentially, this is a function to get the latest ID to listed tokens. It's basically getting the listed information of the latest NFT that was minted. Let's move on to another helper function, which is get listed for token ID. Right. So basically, here in this function, you can pass in a token ID and fetch the listed token for that. Listed token for ID. Again, this is also going to be a view function because all we are doing here is going to return again make the same mistake. I get the same. All right, yeah, this makes sense. So then it returns the It returns the token information for that particular token ID. This will be helpful when we're trying to retrieve data for an NFT in the front end. And I think one last function that we want to implement is getting the current token ID, right? And that would look something like the public view returns, just like the same previous functions. You can fetch the current token from this function if you need it at the front end, right? And this will just return token IDs current. Sweet. So basically, these are the helper functions that we wanted to add to the smart contract, which are going to be super helpful when we want to retrieve data in the front end, right? Now let's get to the more difficult part of the smart contract, where we are going to implement the tougher and the more important functions that actually run the front end, right? The front end will keep accessing these functions for every single page. Before we actually get into the coding of these, let me first talk about the functions themselves. So the first function is the create token function, which is a top level function whenever you're trying to create an NFT, right? So whenever we send, let's say, NFT data to the smart contract to create out an NFT, it actually increments the token ID. It also mints the NFT. It sets the token URI and starts to create a token, basically, right? So all of those important functions of setting the metadata right everywhere is what this function does. And then it passes on the baton to the create listed token function, right? The create listed token function is necessarily encapsulating a part of the token creation process, which is creating the listed token object, right? So the struct that we just saw, the listed struct token struct, is the struct that's being created here, and then it also updates the mapping that maps the token ID to this struct of data of the token, right? Other functions include the get all NFT functions. So if you go to the marketplace, in the NFT marketplace that I showed you, then it is using this function, right? So it basically fetches all of the NFTs on the marketplace from the smart contract. Get my NFTs is the function that's used in the profile page. So where you want to fetch all of the NFTs that you're either an owner or a seller in, this is the function that is fetching those NFTs and showing them in the profile, right? And last but not the least is the execute sale function, where the sale is actually happening. So once the token has been minted, when it's like in the life cycle of a token, when it's being minted the first time, these are the functions that are called. So the create token function, the create listed token function. And then towards the end, like when it exchanges hands for the first time, when somebody else buys the NFT that you've listed, the execute sale function is called, right? And the execute sale function basically does a couple of things, including transferring the ownership of the NFT to the other person, um, also taking care of just the minting, updating the mapping, and transferring the value that was transferred by. So basically, if there's like a buyer and a seller, and a buyer bought zero point zero 0.01 ether worth of NFT, like one NFT, then even in this execute sale function, it also takes care of transferring that 0.01 ether value to the seller of the NFT, right? So it takes care of a couple of things and then finalizes the transaction, updates it on the smart contract, right? So we're going to now very quickly write out these 5 functions, because these are the main defining components of the smart contract. Awesome. Awesome. I think great speed on that. Let's just start executing now. Cool. And before we can start in, I think it's super important for us to actually understand very deeply what these functions are doing, and accordingly just update stuff. Cool. Now we will get to writing down this function. The first one is the function create token function, which actually takes in the token URI of that function and the price that you want to sell this for, right? The token URI is already set in the front end, so you already have a URL with the metadata of that NFT, and that is what you're sending to the backend over here. And then you have the regular keywords like these, right? What's important here is the payable keyword. It tells that create token is a function that is expecting some ether to come in, right? And this is basically the listing price. So when the token is created for the first time, the creator sends this listing price worth of ether, which in this case is 0.01 ether, right? And this is what is needed to create the token in the marketplace. Couple of things, we have to do some sanity checks before we actually go out to create the token, right? The first check is just checking that enough money was sent by the lister, right? The person who's trying to create the token. Send enough ether to list, right? This is the error that it gives. What else? We should check that the price is greater than zero. So just trying to make sure that the price that the person is sending for their NFT is actually positive. You'd be surprised at how many people could send negative values, or if the front end is not doing the right checks. So this has to be there. Yeah, sweet. Now after we're done with this, I think the next step would be to call the safe mint function, where it tells, okay, I want to mint this to the sender. Uh, And the token ID that I want to mint is actually the new token ID, right? So first, before we actually call the safe mint function, I think it's super important for us to update the token ID, right? So we call this function token IDs dot increment, which increases the token ID, and then we get a current token ID, uh, which actually takes in the current token ID that is on at the moment. Cool. And this is the token ID that we're going to mint this NFT to, because the last token ID was the token ID that has already been minted. So we basically want to use this new token ID to perform that, right? Yeah. So basically, the safe mint function is this function that's already implemented in the ERC 721 implementation. Why it's called safe mint, right? I mean, there's another function called mint, and then there's a function called safe mint. Safe mint is especially there because it makes sure that the address that you're sending the NFT to can actually accept it, right? Because if it could not accept it for technical reasons, like it's a contract that cannot hold NFTs, for example, then your NFT would be lost in a black hole, right? There's no way to retrieve it anymore. So basically, you have to make sure that okay, this is a valid contract or a valid address that I'm sending it to. Another thing that we want to do is setting the token URI. So then we will set the token URI for the new token ID, right? And this is the token URI. This is the current token ID. And we are trying to set the value over here for this one. Now that this is done, we will call our other function, which is the create listed token function, and pass on the new token ID and the price for the token, because these are the values that we want to store for this particular function, right? It's red because it's not currently defined, but we will define it. And then you return the new token ID. Sorry. Awesome. Now let's create the function create listed token, right? This particular function will have we'll take the token ID first because we're giving the token ID at the top. It will also take the price of the NFT. And it's a private function, right? So because this function does not have to be called by the front end, we're making it a private function. And then this again has some checks. Yeah, yeah, just some checks. Actually, maybe not. I think I think these covers most of the checks that we wanted to do. So we probably do not need another set of checks right here. Sweet. So then other thing would be ID to listed token. For this particular token ID, you can create a listed token struct, which basically will look like this. And we'll take in all of the values, right? So if you scroll up, you'll see, okay, we first have to give the token ID, right? We then want to give the owner, which is the address that has called this function, right? So basically, this could even have been the smart contract. And then you have the sender. So basically, the seller of the smart contract is the person who has sent this message, right? Then we add the price because the price is the next one. And then finally, we have the currently listed, which is true by default. So, I mean, ideally, we should have added a functionality where you upload an NFT separately, and then you have an option to actually go ahead and mint it. But I don't think we're going to do that for this use case because it's unnecessarily just going to make things complex. So for now, just to keep things simple, all we are going to do is keep it true for now that an NFT on this marketplace is just listed by default. That could be an interesting project where you could extend it later. Awesome. Um, that's that. And yeah, and then the last thing would be to transfer the ownership of this particular NFT to the smart contract, because later when we want to sell this NFT to other people, if the smart contract owns it, then it is easier to transfer it. If the smart contract does not own it, then technically it does not have the approval to actually transfer it, right? So this approval is necessary, and like if you go look at the approve function, for example. Let me search that for you. If you go look at the approve function in Solidity, you'll actually know that these are the functions that you need to call to be able to transfer, uh, to be able to have the rights to transfer any NFT or token, right? Awesome. So there's message.sender, and then we transfer it to the contract, which is the address this, and then what we transfer is the token ID. Awesome. So these two functions actually are done creating the token, and at this point the token is already created, right? If these two go through, then your token is created, your mapping is updated. Congratulations, your NFT is now minted. Sweet. Let's get to the other functions super quickly. uh, I think the next one is your get all NFTs function. So get all NFTs, it's a view function basically, right? So because we are not making any changes to the smart contract again, it's going to be a view function. And what we should try to return here is it's a listed token, right? So it's basically is the name is the listed token and the memory for that. Awesome. So you know arrays in Solidity do not work in normal ways, right? Because Solidity is a relatively primitive language and it's still in its 0.8.7 version as we make this video. Arrays need to know the number of items in that array before you create it, right? So these functions, the get all NFT and the get my NFT functions, will be a little longer than expected because we have to first give it the exact count of the number of items we want in that array. So we'll first run a loop to get the count, and then we'll create an array to actually fill that, right? Awesome. Um, so the count of is the like so we take the count of all the NFTs, right? We do not know. Okay, we're just doing get all NFTs. We're just getting the count of all the NFTs first. Some of the NFTs are probably off the marketplace at this point, which means they will not be the ones that we'll be fetching from the marketplace. For now, it is this. So token IDs dot current is the NFT count. We will create a listed token array, listed token memory, and we will name it tokens. Listed token NFT count. So what we just created was an array of items with the type listed token, the type that we defined up in the code. Awesome. Current index equals to 0. Right. For Uh, Now we're going to write a loop to actually go through this entire thing. Basically, go over each and every NFT and see if uh, go to I plus one, right? Just see if we can actually fetch that. So just current ID. So I'll just copy paste the code a little bit so that it's quicker, and then we can go over the explanation. Feel free to take your time and then go ahead and write it. Awesome. Essentially, what we're doing here is that we have the NFT count, which is the number of NFTs in the marketplace, comes from the token ID's current value. We create a listed array of listed tokens, which will have each of those NFTs, like the details of that. We then go over each of those NFT counts, right? So we go over it one by one. For every NFT count, basically for every NFT token ID that we go to iterate over, we create this item which is the which is fetched from the mapping, right? So remember the mapping that we created for token IDs to the listed tokens. This is where we just fetch that and create an object, right? And that object is what we will be returning, right? So when the marketplace is trying to request the get all NFTs, we will actually be creating this object and then storing it in this array. So the array that we've created, this is like we keep adding to it every time we loop over an NFT, we just add that NFT's object to this particular array, right? And then we do an index plus plus. Something interesting to see here is that we have this NFT count going separately, and then we have another variable called current. So basically, we have two variables here, which is current ID and the current index. The current ID is like it goes from values 1 to NFT count, right? As we iterate over this, and these are the values that are stored in the ID to listed token. But when we are when we are putting the values in the new tokens array, we're actually starting with current index, right? So if you clearly notice, and people might make that mistake, that current ID and current index are two different numbers. At the time when current ID is 1, because I equals to 0, current ID is 1. At that time current index is 0 because it is initialized over here, right? And then it is incremented later. So for every current ID, like this goes from 1 to NFT count, and this will actually go from 0 to NFT count minus 1 as we store these, and then we return the tokens, right? So end of this function, we have returned all of the NFTs back to the front end. Awesome. I hope this has been clear so far. The get my NFTs function is going to be pretty similar because I mean it has similar functionalities. All it will have additionally is a check for like for every NFT that we'll check that if this particular NFT is like owned or sold by the person who's calling this function. Right? So the person who's calling the function is the person who's logged in the front end, and this is the person whose NFTs we want to show. So we'll just filter out all of the whole NFTs for the NFTs that are owned by this person. And this is what it looks like. So returns listed token. Again, I'll just copy paste the code here so that it's easier for us to actually just explain it, and you don't have to bother about reading every statement with me, but you can just focus on understanding the explanations of these, right? So a couple of things going on here. We first, just like the previous one, try to fetch the total item count. So this is the list of all of the NFTs in the marketplace. We initialize some variables which you'll know the significance of later. We first run the first loop, right? So we'll run a loop on all of our items, so from 0 to total item count. And what we try to see is in the mapping that we had, right? And this is the most important mapping, right? You see this keep coming over again and again. The the mapping that we have, we try to see if ID to listed token I plus one dot owner is equal to message dot sender. So what we're trying to say is that for the token at position I plus one, is the owner that we've already stored, like when the NFT was created, uh, equal to the message.sender, right? So if this message.sender is the owner of that particular token, then this is the an NFT that we want to show in the My NFT section in the profile, right? Likewise, a parallel check is that if that token seller is equal to message.sender. So what we're trying to do here is that either sorry, if either the owner is message.sender or the seller is message.sender, in both cases we just increment the item count, right? And the whole point of this for loop is to get the number of items that actually belong to that person, right? So if there's like 15 NFTs on the marketplace but only 7 belong to that particular address, this function is supposed to return just those 7, and the number that comes out of this for loop, the item count, that number is actually 7, right? And not 15. So, and that's helpful because in the next loop, we'll just loop over those 7 NFTs and not take care of the 15 NFTs, right? We wanted to create this array, right? And when we want to initialize this array, we want to pass the item count, which is coming from here. That number is 7. And so we create this array of 7 values over here. Now, again, this loop is very similar to the same function in get all NFTs, only there's an extra condition. So what we're trying to do here is that the ID to listed token owner equals message or sender, or seller equal message or sender, same constraint. If this is true, then do the same thing, right? Basically get the current item, like if for a particular item, let's say at index 5, that particular token has either the owner or the seller as the sender of this function, right? The person who's called this function. If one of those is true, then you take that particular item out of the ID to listed token array, the mapping, right? So you basically take that ID out from the ID to listed token. You take that item, you save it in your list of items, and then you increase your index by 1, right? So all we're trying to do here is populate this array items, which is also here, with all of the tokens that actually belong to that person, right? And then in the end, basically, with the help of all of those things, we have this array items, which is just those NFTs that we're concerned with and nothing else. So basically the 7 NFTs that we wanted to, not the 15 NFTs, are here. Awesome. All right. Okay. Awesome. I hope you get it. Basically, these are the two functions now that we have sorted, which is get all NFTs and get my NFTs. All you can see is that if you go through this peacefully, you'll see that these functions are very similar, except for the fact that there's one condition that is being filtered upon, right? And just that one condition is what makes a difference between all NFTs and my NFTs. Just that. Awesome. Now we are left with one last function, which is the execute sale function, right? The execute sale function is again one of the most important functions here, and let's write this one out, right? Instead of copying, I'll just walk you through actually what this function does. Again, so all we need to execute a sale is the token ID of that particular token, right? It's again a payable function because when you're executing a sale, you have to send some ether, which is the price of that NFT. If you don't send it, you don't get the NFT, right? Which also brings us to our first check, which is require that the message dot value is equal to the price of the NFT. And then it says, like, if it is not, then it says, please submit the asking price for the NFT in order to purchase, right? Uh, And then what we do is, let's say this happened, right? What we want to see is that, okay, the price was actually ID to listed token ID dot price. Okay. This is the value that we need up, sorry. So before we call this require, we have to call this statement because it will see if, like it will get the value of price that we want to compare the message dot value with. One other thing that we want to fetch is the seller address because we will be sending the ETH that came in, right? So the price that was paid for the NFT, let's say 0.01 Ether, we will be sending that to the seller here itself in this function. So it comes like this, token ID dot seller, right? Cool. Message dot value, by the way, if it's not clear enough, is the value that is being sent when you want to execute the function. So it is the price of the ether that has been sent when you want to execute the function. It's like the NFT price. If it's 0.02 ether, this is the like message dot value will equal to 0.02 ether. Awesome. So and now the next thing that we'll do is actually update the token which has the NFTs. So I need to list a token ID dot currently listed equals to true, ID dot seller equals to payable message dot sender. Right. So what we do here is that we update the currently listed to true, which is, by the way, true at all times, to be honest. But if we wanted to make this false, like I'm just putting it out here so that when you want to extend the functionality of the marketplace, so that people can list when they choose to, and it's not listed by default, at that point we can actually change this true to, like if it was false, then we're switching it to true or vice versa or whatever, right? So basically at that point you can extend the functionality. So the point of this statement is just to keep that in mind. And then we will also do increment the items sold. Sweet. Now a couple of last things in this function. When that is actually happening, we want to transfer the token. So we will transfer it from this address. So address, this is basically the contract address, right? So we'll transfer it from this contract. And remember, when we were creating the token, we had actually transferred it to the contract by address this, which means the contract is now the owner of it and it has the rights to be able to transfer it. Message.sender and token ID, right? So we transfer this. Now, this is where it gets a little interesting. You can try to actually not have this statement and you'll see an issue with this. So essentially what is happening here is that we're doing a transfer of NFT, right? Which means the NFT is being transferred from this address to the sender of the message, basically the person who's requested to execute the sale. Now, this person, the message.sender, is now the owner of the NFT. But if we want to make a future sale happen, how do we do that, right? Because the issue then would be that this NFT is actually owned by the sender and not by the contract, which means the contract is not approved to be able to sell the NFT on the behalf of the actual owner, right? The owner has to approve the marketplace contract, this particular contract, to be able to sell this NFT. And that is the challenge to solve which we actually note down this function. What else? So we finally transfer some money. So to the owner of the smart contract, we transfer the list price. And to the seller who has been selling this NFT, and now that the sale is complete over here, right? Then the seller receives the message.value. So like we said, message.value was supposed to equal to price of NFT. Message.value is here, and that is what the person is transferring. Oh, all right. Awesome. Do you believe that you've written a smart contract for an entire NFT marketplace? How cool is that? Like at the end of this, you're going to get an NFT that you've completed the Road to Web3 Week 7, which is super cool. But you'll also get the bragging rights that you wrote an entire smart contract end to end. And how big is that? It's like 140 lines. Wow, it's one of the biggest smart contracts that we've written at Road to Web3 so far, and I'm excited for you to learn it. Uh, I mean, in the comments of this YouTube section, we'll also have a link separately to the smart contract, which is heavily commented and hence will make it easier for you to understand. So if I've misexplained anything or if there's something that you did not understand while we were going through the smart contract, make sure you go through that link in the YouTube comments. And I think that'll be super helpful and should explain to you whatever is happening for this smart contract. This is awesome. I think we've gotten more than halfway into the tutorial. It's super exciting to build this with you. And I think as you learn this, you're basically learning a lot of ins and outs of Solidity, right? The smart contract is now done. The next steps would be integrating the smart contract with the front end, which will keep relatively quick. I mean, we will not dive as much deeper into explanations as we did into the Solidity contract, but we'll still make sure that I go through all of it with you. Amazing. So now before we jump into doing the front end and integrating it with the smart contract, let's first deploy the smart contract that we've made with so much hard work, right? To deploy the smart contract, there will be a couple of steps, right? When we get to deploying it, I guess the first thing that we should do is update our Hardhat config. So, like I said earlier, Hardhat is one of the most important tools in a Web3 developer's toolkit, and it should be installed when you do an npm install in the repository. If for some reason it's not installed, you should go check out the npm package page for Hardhat and install it in your system. Okay, makes sense. Now, you probably already have a Hardhat config in your project that looks somewhat like this. What you need to update here is two things. First is inside Goerli, since we're going to use Goerli testnet, the URL, which is your Alchemy URL, right? So basically, you have to go to your Alchemy dashboard, fetch the URL for your project or the app that you've created use on Goerli, and then put that link over here. And the second thing here is the private key. So basically, why we need to update it is because we're going to deploy the smart contract to the Goerli testnet using Hardhat as a medium, right? So we basically tell Hardhat, okay, here's the customized RPC URL that you need to use. This is the account in Metamask that you need to use the funds from, right? So basically the ETH that you need, the gas fee that you need to deploy the smart contract, take them from this Metamask account. And to authorize Hardhat to do that, we just give the private key directly to Hardhat. Now, be very careful to not push your private key to production, right? So to GitHub, to any other platform, to any public data source, just do not push your private key. This is for your own local changes. If you need to deploy it, like basically deploying smart contract is more of a local exercise. You'd never need to share your private key anywhere, right? So whatever changes you make here, make sure you do not commit them and do not push your private key. Cool. To get your Alchemy URL, you should very quickly just go to the Alchemy website, right? So dashboard.alchemy.api.io. If you do not have an account, go to alchemy.com and create an account. If you already have an account, then no worries. You should just log in into that account, right? So I already have an account. I'll just go ahead and log in. Obviously, I have an account. I should have an account. So I just go and log in. You see that I've created, all of these different apps for different networks for this marketplace. The one that we're going to use is the Gordy one. And then if you click on View Key, you'll be able to see the key for this particular app, right? So there's the key, there's the HTTP URL and the WebSocket URL if you click on this. So just take out the HTTP URL from it, and the HTTP URL of this app that comes from clicking on View Key, right? This is what you have to place here on the URL. Make sense? And the second thing that you have to place, which is the private key, like I said, comes from your MetaMask. So I'm assuming that you're logged into MetaMask. You have this particular like a particular account created on Gordy, and you may or may not have some funds on it, right? If you want to export the private key of this account, assuming you're going to use this for development, you should just go to like the three dots over here and click on account details, right? As soon as you click on account details, you see an option to export private key. When you click on that, you'll see your private key, right? Just make sure you do not show it on any live stream, live cast to any other friend, because I'm not doing it right now, right? So just make sure your private key is hidden and it's only private to you, because like if somebody has access to your private key, right, they can do anything with your wallet. They can delete the wallet, they can transfer out funds, they can do anything they want. So basically, do not share your private key with anyone. At this point, you can see your private key from here and go out and paste it in your smart contracts Hardhat config. What is important here is that you may keep it an array, right? So this is an array of accounts actually. You can give one. I will just give one for this tutorial, but you can give like 5, 7, 10, whatever you want. You can give Hardhat options, and then you can choose from it, right? So basically, we'll go ahead and deploy that using that. One other step that is super important here is for you to go to the Goerli Faucet, so goerlifaucet.com. This is powered by Alchemy, and so you can request Goerli ETH from here, right? It's like free ETH, no cost. You can just go and put in your address. We will send you some ETH, and then you can continue to develop using that. Now, you can copy your address from here. So you click on it, you will copy your address. You can paste your address here, right? And now you can click on send me ETH. Now, if you click on send me ETH, it will actually send you some ETH, right? If you're connected, it will send you 0.05 Goerli ETH. If you're not logged in, it will probably not work for you. So you can basically log in from the top right. If it's not logged in, as you can see, it's logged in for me. So just make sure that you're logged in, put in your address, and then hit send me ETH, right? Yep, there's this really cool animation. People love this. People love this. So when you use Goerli Faucet, if you love the experience, please share it on Twitter, tag Alchemy platform. Um, and yeah, it should show me some Goerli ETH. Right. Let's just wait for it. It'll probably. Oh, yeah, I think it already showed up. Did it? Yeah, basically, we already have ETH come that has come in from this faucet. Okay. Uh, Actually, it hasn't already come in, but it will, right? So essentially, the idea is that you will have some Goerli ETH. You have updated your Hardhat config. You've added in your Alchemy URL. You added in your private key. You should be able to now deploy on the chain, which is the Goerli chain, right? Now, I will take a small pause to actually go out, update my own private key here in the Hardhat config, and I will not be sharing it on screen. But please make sure that you do that as well. And when we return, we can actually just go ahead and execute the deploy command. Awesome. I've now updated the private key for myself, also updated the Alchemy URL, and I hope you have done that too. Now, and assuming that the Goerli ETH has hit your wallet as well, you should be able to now execute the deploy command. Deploy command is something like this. So npx hardhat run minus minus network Goerli scripts deploy.js, right? If you run this command, you should be like it should deploy the smart contract for you, and you'll notice that it will automatically deduct funds from your MetaMask account, right? So let me run that. It takes a bit for it to deploy naturally because Goerli it's a test net, it's on Ethereum blockchain, takes a while for blocks to be mined, so it takes its own sweet time. But when it does get mined, you will be able to see that it says, okay, Solidity contracts compiled and deployed successfully, and we've made a change such that when this is actually deployed, it saves the address that this contract is deployed to in a JSON file, right? So right after it's deployed, I'll just go over the deploy.js file as well so that you have an understanding of how the whole deploy function happens. The code for that is already in the repository, so I will not make you write it, but at least you should for sure understand it, right? Awesome. I think it is now deployed. And let me switch over to the other screen to show you how the deploy.js script works. Awesome. Cool. In the deploy.js script, it's not super hard, right? It's no rocket science. All it does is a couple of things. It imports in the ethers library from Hardhat, so basically Hardhat ethers, uh, and it also gets in FS. So basically, what we're going to do is that we'll get a provider and a signer. We'll create the smart contract object using the smart contract code, and then we'll go ahead and deploy it to the blockchain, right? Uh, I'm not sure if in Road to Web3, we've already covered providers and signers, but you should go read their standard definitions online. So provider is basically, for example, MetaMask, right? So in our browser, when you actually want to deploy something, you can use MetaMask's provider. And it's basically a set of functions, helper classes that will actually interact with the blockchain and go ahead and deploy it, right? So you can use Metamask provider, you can use your own provider, do any of that, right? And then the signer is actually an address on that network that will actually sign off the transactions for you. So it's important that anytime you are trying to deploy to the blockchain, you need a provider, which is the, in a way, the node or the proxy service that will help you deploy to the blockchain. And then this, and you need a signer, which is the address who's the address that actually signs off on those transactions, and if needed, actually funds those transactions as well. Make sense? So yeah, we basically get sign. We do the ethers.get signers function, which gives us a list of signer, and then we take the first value in that array, which is the deployer, right? Notice that this is an array, so it just takes the first value that is returns by this command and then assigns it to deployer. Uh, this line is just for good info, the balance of that particular signer. Like if you wanted to display helper comments around, okay, the balance is too low, you cannot deploy it, stuff like that, we will be calling this function. We get the contract factory, so you can check out HRE, like Hardhat Ether's documentation, to read more about get contract factory. But essentially, we're giving it the name of the smart contract, and then we get like a contract factory object, like it's like a class, and we're getting the object of that, and this is what will be deployed. This is what the provider understands when it wants to deploy. So you take this marketplace object, right? And this marketplace object has come from the contract factory, and then you go ahead and deploy it, right? And then we await this event. So basically, it's a function that tells you, okay, the marketplace has now been deployed. Awesome. So with all of these things, I think the marketplace gets deployed. It works out, and what we want to do now is save the data of that particular execution, right? So we have the ABI, and you should look up if you do not know more about ABI. But there's ABI and there's the bytecode that gets generated every time a smart contract is deployed to the chain, right? And ABI is like it's like a interface which has the definition of all of those functions in the smart contract, and then and when we want to retrieve it later, so let's say you want to access the functions of the smart contract, you want to send requests to the smart contract, you will need the API, right? So which is why we're trying to save it here. We save the address that the smart contract was deployed to, and then we also save the API because it will be needed when we want to access the smart contract later. And just like that, we have this data point which is essential to fetch the smart contract later. We save it in this file, right? So in the SRC folder, we've created this file called marketplace.json, right? This one, where we actually go ahead and deploy the smart contract. Does that make sense? Cool. Yeah. And once you run that command, once this happens, you should see the marketplace.json file being created. If it's not created for some reason, just check out that you're including the right packages and you have like them installed in your repository. Like it is possible that for some reason you do not have any of these installed, so just go ahead and install them. Awesome. So you should have, by the end of this, you understand the deploy script, you are going ahead and deploying your smart contract, you will have the contract address where you actually deployed it. And you can take that contract address, go to goerli.etherscan.com, right? So if you go to goerli.etherscan.io, sorry. So here, if you paste the address, the one that you get from marketplace.json, you should be able to see that deployment, right? So in our case, the contract that we deployed to, if I put that address here, I should be able to see that it was deployed just 2 minutes ago and any other details that I need to see. Great. So with this, you've created a smart contract. You've also deployed, yay, you've deployed your contract on the Goerli blockchain, right? On the Goerli testnet. This is awesome. Like you're already on the testnets and you're playing with testnets, which means you're a good developer now. Cool. Now next step, let's just go over the front end really quickly and integrate our smart contract with the front end. In the next step, as we start to integrate the front end with the smart contract, I think one very important step is integrating Pinata, right? So we'll just spend a little bit of time on IPFS and Pinata, which is an IPFS platform, and see how to set that up, right? So basically, in this particular page, when you try to upload an NFT to a marketplace, as you fill in details and hit submit, this list NFT button, The data of your NFT is actually uploaded to IPFS, right? That is the idea. We do not want it to be in a database. We actually want it to be in a decentralized store like IPFS, right? And this is where it's required. Now, to interact with Pinata, and this is Pinata, by the way. So if you go to pinata.cloud, you'll see the Pinata website. You can go create an account, log in, or try for free if you do not have an account already. Um, but the idea with Pinata is that Pinata is a decentralized IPFS store. It will give you a very easy interface to use and access IPFS. So basically, you can upload files to IPFS. It will return you a URL, right? There are APIs for that. You can upload entire JSON slash metadata to IPFS. It will return you a URL for that, right? And then, so basically, the way we do this is when somebody hits the upload NFT button right here, we actually first upload the image to IPFS, get a URL for that image, then take that image URL, plug it into the rest of the metadata, right? So we have all of the metadata of the NFT, which is like name, description, all of this coming here. We make a JSON out of it. And in that JSON, one of the fields is image URL, which becomes this new, the Pinata URL that we just got, right? And then this entire metadata, we upload again to Pinata or on a separate URL. And then the final URL we get, that is the token URI. That is what we pass to the smart contract. And that is what we use later when we want to retrieve the data. Make sense? On Pinata.cloud, just go ahead. I already have an account, so I'll log in. And I'm already logged in, so it will probably just log me in. If I go to files, you can see a lot of these files have been uploaded, right? What you want to probably do now is actually start to create a new key, right? So once you've created an account, you're logged in Pinata, you can go to the top right and click on API keys, right? This will actually help you generate an API key to be able to use for your service, right? Because you need like a key, like secret, something like that to make sure that all of the requests hitting your Pinata account are actually yours, right? Makes sense. Cool. So I actually already clicked on the API keys, and now it opens up this page where I already have some keys which are masked right now. It's hidden, but you can go create a new key. Right? So if you click on new key, click on admin because you need admin access. You want your keys to be giving you access to almost everything on Pinata. So just take a key name. It's like, I don't know, test, like put in a marketplace or something, marketplace 2, and then click create key, right? This is info that is only shown once, so please make sure that you copy this key and a secret somewhere safe, right? So basically all three of them, so just copy up all three of them and save them somewhere safe so that we can use them when we come to actually our code. Make sense? So this should be sufficient to be able to upload to Pinata, and you probably don't even have to upload open like Pinata again. And all you should do is just go ahead and integrate this in your app. Make sense? Cool. We will now, at last, in the case of Pinata, we'll just go over a couple of details here. Um, so we already have a pinata.js file, which has two very important functions, right? One function is upload file to IPFS. This is the function that runs when you want to upload an image to IPFS. And then the other function is upload JSON to IPFS, right? So the upload to file IPFS function runs. It takes in the file as an input, basically the image. It goes ahead, uploads it using the Pinata API key and secret that we just got. And then when it gets the URL back, it goes to upload JSON to IPFS. Very quickly, it does a couple of things. This is the endpoint. Very important. You can look it up, read about it. It's pin file to IPFS. This is the Pinata endpoint through which you can actually upload this image to IPFS. They call it pin, right? So in Pinata, call it pinning to IPFS. And then a standard request. This is the request format that they expect. So basically, you should be sending this as well. The important thing is the file here. So make sure you're sending the right file object. I'll show you how to do that. And then there's the regular Axios request, right? This Axios request hits this Pinata URL, which is /IPFS. Um, Actually, this is what it returns. Sorry. So basically, it returns this Pinata URL where this has the IPFS hash. And the stuff that goes in is basically these parameters, right? Which is Pinata options, the data that you want to send, which is all of this metadata, right? So the metadata is here. Uh, it also has the file. So data has the metadata, and data has the file. So data.append file and data.append metadata. And after taking in, so basically it took in the file, it took in the URL that it wanted to hit, it took some other, custom metadata, that custom parameters that the request uh, expects, and then finally it took the key and the secret, right? So the key and secret that we copied in the previous step is what we put in over here. So this function finally, after it's done, after the Axios request is done, it returns this particular thing, which is success true if it is successful, and a Pinata URL if Pinata URL, which is basically the URL of the final URL where the image got uploaded, right? So that's the IPFS hash. This is basically returned by the execution of the Axios request, right? So Axios request, send in a key, send in a secret, send in the file, send some other data. It returns the IPFS hash of that particular data, like the file where it was uploaded, and you add the IPFS hash to this URL to get the actual Pinata URL that you should be using. Make sense? So that's the upload file to IPFS function, and this is the upload JSON to IPFS function, where the URL is pinned JSON to IPFS. So we basically, in this function, take the metadata, which also has the image URL, plug into Pinata. Similar stuff. You send the JSON body, you send the key and the secret, again the same that we got in the last step, and you get back the IPFS hash, which you integrate with the URL. Make sense? So basically, these are the things that, like the two functions that we will not be writing here, but I've explained it to you enough that you should be able to understand what's happening over here. And these are the functions that we'll be using in the sell NFT component, basically the create NFT, where we have that form. And one last thing is the key and the secret, right? So these are coming from my .env file. So if you see clearly, you basically create a .env file over here. Actually, I'll actually just create it, right? So something like, all right, you just create it like this, say .env, right? And then you put in parameters in it, like React app Pinata key equals to, and then you add your key in here, and then you go like React app Pinata secret, add your secret over here, and likewise, right? So basically, these are your environment variables that can be accessed by your app, and then for your Pinata application to access it, you have to put it over there. Make sure that you name the variables in the .env file starting with React app. This is important for React to pick it up. But yeah, you basically have, and this is important so that you're not pushing your key and secret to production code. You have it in your .env file, and your .gitignore file actually has like an entry for .env. So these variables do not get pushed. Make sense? So essentially, you have the key and secret here coming from the .env file, and through that, your entire Pinata code can run. Now, what we're going to do now is like jump into the component straight. We have all of these components written for separate pages. There's sell NFT, there's profile, NFT tile, NFT page, right? Sell NFT is like the form, profile is your own profile where you see your own NFTs. NFT tile is the individual tile in the marketplace for a single NFT. It's the designing of that. NFT page is the entire page for NFT. So if you click on the tile, the page that opens up is the NFT page. Nav bar is the navigation bar at the top, and then marketplace is the main screen that opens up when somebody opens it, right? So basically the OpenSea screen that I showed you earlier, which has all of those tiles in it. Cool. So let's hop on now into sellNFT.js, where we'll actually use the Pinata code and go ahead and upload data. Great. All right. Let's get to sell NFT component, where we're going to try to integrate the uploading to IPFS, the Pinata part. Sell NFT, to be honest, will be by far one of the most complex, like in comparison to other components. Sell NFT is going to be much more complex to integrate with the smart contract, but do not fear, because everything else is way easier than that. Awesome. So I think the first thing that we will do is to allow the upload of file, right? Basically on change of the file type, which is like, if you look at this input type, this is the file being uploaded, the image file in that form, and we can add the function here that we want to run on the change of file, which is this, right? And then code it out. So basically async function on change file, right? Files, dot target dot files. So we take the first file out of the e.target object, and const response file. Okay. Cool. So basically, this function goes ahead and calls the upload file to IPFS function, which was declared in pinata.js. It tries to upload it. If it's successfully uploaded, remember the JSON that this function was returning? That function had a success equals to true if it was a successful request. And so if it's successful, we just save the file URL to a Pinata URL, right? If you're familiar with React, this is the way React state works in functional components. If you're not, probably go read about it. And like it's not super hard. All there is basically like we've created this variable state variable file URL, and we have given it a function set file URL, and use the use state function here in functional components. So what use state does is it creates two things. It returns two things. One is that variable itself, so a value for that, and then two is a set function for that, right? So basically we are assigning the set function to this and the value itself to this. Now every time we want to update the file URL, we'll be calling this function. Simple as that. So we're just calling that function here to update the Pinata URL again, right? So basically when the file is uploaded, when you actually like click upload, put in a file, that the name comes up, that's when it will get uploaded to IPFS. Another function to upload, and honestly, the try catch, error handling, test cases, all of that is not going to be the best in this tutorial. We can probably do a separate tutorial for that, somewhere around week 8 or week 9 for O2 Web3. For now, it's just going to be this code that works, right? So we'll just make sure you see the functionality, you see how that works, and then feel free to add better try catch, better error logging, all of that by yourself. Approve metadata to IPFS. So uploading the metadata to IPFS is one function. And the another function that we'll need is list the NFT. Okay, right. So the list NFT function is the default function that's called when somebody hits the submit button. Okay, that's the idea. So basically here we have the list NFT function, and that is the one that's called. Now we do all of the things here, right? So when somebody hits list NFT, we first go ahead, like the file is already uploaded in this function, but here what we try to do is take the file URL, try to upload it to the metadata to IPFS, get the returns for that, and then also, so once you're done uploading to IPFS, you get a token URI. Now send that value to the contract and add that value to the contract. Makes sense? So then const metadata URL. Provider dot get signer, please wait. So what are we doing so far? We would just get the metadata URL, right? So you upload the metadata to IPFS. You have all of the data in the form params, right? So this thing is like name, description, price. These are the details that are updated. as soon as the data is entered, right? So basically, each of these input fields in the form, they have this update form params function, which gets updated as soon as that field is edited. Simple as that. Right? So this value, like you just go and upload metadata IPFS, which is this function, and the values are already there in form params, so you will not need it. What else do we do? So we get like a provider. This is interesting, right? So window.ethereum is basically the object injected in with the window, like the browser window, by MetaMask. So the window.ethereum object returns that sort of object which MetaMask is injecting, and then with the file of the ethers.providers.web3 provider, we convert this window.ethereum object, extract the relevant values from it, and get the provider object that we want, right? This provider object is our gateway to uploading data to the, this is our gateway actually talking to the Goerli testnet. So if you want to, like the deployed contract on Goerli testnet, we want to fetch it, we want to look at it, this is the way we do it. And then provider.getSigner just gets you one of the addresses as the signer. Awesome. Now that we're done uploading it to IPFS, we have the URL. What we're trying to do is get a provider, signer, get the contract, and go create the token. Remember the .create token function that we created? That is the function that we will now be using to actually create a token. Make sense? Let contract equals to new ethers dot contract market. Marketplace dot API signer. Okay, so what have we been doing over here? All we're trying to do is create the contract object, right? So we use the ethers.contract method. To it, we pass the address, right? So remember that when we were deploying the smart contract, we had a marketplace.json being created. That JSON had the address of the deployed contract and the ABI of the contract, right? Now is when that comes handy. So when you try to fetch that contract object, you have the marketplace.address object, like address value being passed, and the marketplace.ABI value being passed, right? And the signer, which we just got in this step. So these three values, when they're passed, that actually gives us the right contract object with like the right address that we want to interact with. And then we can pass on any other functions and call functions that we want to. These three this is basically just data massaging, right? So like the price that we got was in numbers, like we get 0.01 ETH, it's like an integer, and we're just parsing it in ether. Basically, we are using ethers.utils library and the function parse units inside that to actually convert this normal decimal value into like an ethers value, which is what the smart contract will understand, right? If we didn't do this and just send the form panams.price value to the smart contract, it would not have been able to get it. So we have to convert it. Awesome. So listing price, and then this one is just us getting the list price, right? Remember when we wanted to create a token, we want to pay a listing price. We use this get list price function defined in the smart contract to get that number, and then convert it to string, so that when we want to send that value to the create token function, we're able to. Make sense? Now we'll just be calling the create token function, and the create token function will go create your NFT. Yay, let's go. So await contract dot create token. You pass in, like, okay, what were the parameters? What are the parameters? Right? There was token URI, there was price. Okay. So what are the parameters here? We have the token URI coming from here, which is the upload metadata IPFS function. So metadata URL, and the second one is price. Okay. And then we want to pass on the listing price, right? Because we want to pay that kind of fee. We have to for our function to get accepted. Otherwise, it would return an error and it will not go through. and we do this await transaction dot wait, right? And now is the time when, okay, I should also do a catch, right? So we will just, just a simple alert. Okay, upload error plus E. Make sense? So essentially, all that we're doing here is just like it's very basic. The try catch. Please ignore my disinterest in creating great try catch statements, good errors, because that's just not the point of this tutorial. But the idea here is that we just want to make this the core concepts clear to you, so that you have the power to go to however build you want to build it. Right? Just change however you want to, but we want to explain, get through the core concepts. Awesome. And then, so when this is actually uploaded, you say successfully listed your NFT, right? Update message. So basically, this message is the message that comes, when you're uploading the NFT. Please wait, uploading, it will take 5 minutes. So we're just making sure that we make that message clear once upload happens successfully. And yeah, reset other variables. Name, description, and price, the three things that we were initially editing. Okay, and sorry, and the last thing is, so what we're doing here with this window.location.replace is actually just redirecting the website to the marketplace homepage, right? Basically, once the upload happens, you see successfully listed NFT in the alert, you hit OK, it should redirect you to the marketplace page where you'll now be able to see that, oh, right, my NFT got a great. One last function that we want to sort out here in this sell NFT page, sell NFT component, is the upload metadata to IPFS function, right? So we basically, like when you hit the submit button, the list NFT is called. List NFT calls the upload metadata to IPFS function, right? And by the way, the upload file to IPFS was already called way before when you uploaded the file, right? Now it calls upload metadata to IPFS function, gets a metadata URL, and then the rest of the interaction with the contract happens. So just very quickly, metadata to IPFS, all it has to do is it has to call the Pinata functions, right? And like the Pinata function will return it the URL that we want to see. So again, similar to upload file to IPFS, but slightly different because we'll be doing one or two small checks here. So we check that the name, description, price, all of these things. First, we fetch them from the form parents, and then we want to check if like none of them should be empty, description or not price or not file URL. Like if let's say the file URL is also not hit by this time, like we haven't obtained it and somebody like really quickly clicked it. So then we create something called the NFT JSON, which will have all of these details, right? So it will have the name, description, price, actually image, file URL. Okay. By the way, this is a shorthand to create like JSONs in JavaScript. And we could have done the name colon name, the description colon description, but this creates it with the name of that variable. So basically, you can do this shorthand as well. Try catch error. Just a simple console.log error uploading JSON metadata. Awesome. Const response upload JSON to IPFS NFT JSON if response dot success true. And again, same thing, basically it returns a JSON that says that the response success is true, and if it does that, that means yes, you uploaded your JSON to IPFS. Okay, so console.log upload JSON to Pinata uploaded JSON to Pinata, and then here's the URL, which is response and other data. And so you return response.pinata URL, right? Awesome. I think, yeah, that looks like it. Basically, you have on change file function being called when the file is uploaded, list NFT function being called when the list NFT function, whenever you hit the submit on that form. Uh, this does all of the interaction with the smart contract. So smart, like at the end of this smart contract also has the NFT object. At the end of this IPFS URL is also created. These two are the helper functions. And by the way, we already did the imports earlier, so you didn't have to do it, but just make sure to look at them and they will make sense. All right, I think, yeah, I think we got it, Let's just test out our set NFT and let's see if it works. Okay, but before we can test that, if the sell NFT function works, we need to first make sure that we're able to connect our wallet with the website, right? Because the website currently in the way it is written, it will not work if the wallet is not connected. So I'll just go ahead and paste some code to the navbar.js file. I do not expect you to know it at this point because I'm not going to go through all of it. It's a lot, but all I can definitely do is very quickly skim over it and give you an idea of why we've written what we've written. Make sense? So this is what the code is. There's like three functions over here that we've pasted, and so this is the connect website button, which is basically connecting the function that connects your MetaMask to the website if you click on the connect wallet button. So I will add this as an on click to this. So in like the navbar connect button, which is here, right? This button, uh, yeah, this button. This is what it will connect to this particular function. Awesome. Very quickly, what's happening here is it gets like this function is the function that gets the address. So basically, if you're connected and signed in with the wallet, this is the address that you're connected to. So this is what it will show in the nav bar and other places for verification. This is the update button. So basically, as you click on connect wallet, it's like a blue button with connect wallet written in it, right? When you log in, it becomes connected and it's green, right? To signify that you're awesome, you're connected. And then there's this third function, which is the correct website function. This is an awesome function. I love this function because the first thing it does is that it checks which network you're on, right? If you're not on the Goerli testnet, whose chain ID is 0x5, by the way. So the Goerli testnet chain ID is 0x5, Ringv is like 4. And if you're not on Goerli, it will ask you to switch the chain, right? Which is the method over here. So switch Ethereum chain if the chain ID is not equal to the Goerli chain's ID. So we do that over here, and then we actually request to connect to the account, right? So we basically display the accounts, account 1, 2, 3, 4, like I showed in the video earlier, and then you can go ahead connect with it. So this is the one that switches the network, connects to the account. And then use effect is just here all we are doing is making sure that when the account is changed, we reload the page, right? So this is the function where, okay, it's listening to this event called accounts change, and if the accounts change, then it just reloads the website so that we can see, okay, now that it's not connected to the previous address, it's connected to another address. And this one just make sure that it updates the connect wallet button if the account is already loaded. So basically it keeps checking that if the account is already connected, you just toggle the connect button, update the button, which is this function, the update function button, and you just make sure that the right button is reflected. So there are these three functions which I quickly skimmed over, but this is what we need to actually be able to connect with the wallet in the right way. Okay, we can actually test this out. I'm already connected, so I'll just disconnect it, disconnect each of my wallets. So if I go here, it's connected, I disconnect it, and then I disconnect this as well. As you can see, it became like the connect wallet blue button, and now we cannot see any NFTs over here. Sweet. Let's try to connect the wallet now, and let me also switch my network for demonstration purposes. It's now on Ringv. If we click connect wallet, right? It shows, it asks allow this site to switch to the network, which is awesome. Not a lot of websites do this. So if you have this in your DApp, you're awesome. So you switch network. It then asks you, okay, can I connect to any of these accounts? You can choose which one you want. For demonstration purposes, I want to connect to account one, for example. I'll just go ahead and connect with it, right? Awesome. So it basically, like, you can reload it. It will show that, okay, no data to display. And then like there's no NFT here as well. That is out actually yours. But it says, okay, you're connected, and then you're connected to this particular address, right? So the connect, because of this, that in the navbar, the code that we've put in, the connect works now. To be able to see the NFT that you recently uploaded on the marketplace, it's super important that we also integrate the contract with the marketplace as well, right? So the contract is actually just fetching all of the NFTs that are actually uploaded to the contract and not showing dummy data. Right now, what you see on your screen is just dummy data, right? I mean, random data, random images on IPFS. Not random, actually. Alchemy cover images on IPFS, which are, by the way, super important. So we go ahead, add some more code to our marketplace. Just copying it over. Sweet. So essentially, this is the code that in our marketplace will get fetch NFTs. I'll quickly walk through this. This does is, again, just like the previous example in like sell NFT, it gets the provider and the signer. Provider it gets from Metamask that injects the window.ethereum object in our browser, and then it gets the signer. It creates the contract object just in a very similar way with the address and the ABI, and then it gets all the NFTs, right? So basically, the get all NFT function that we wrote down in our smart contract is useful now, right? This will return like an array of all of the NFTs, which by the way currently is empty. Like for this contract, we haven't uploaded any NFT. Yeah, let's see how that works. And when I mean, for example, when it's not a non-empty array transaction, we are going to go over that, right? So map over all of the values and extract the data that we want, right? So we get the token ID from this transaction object for a particular NFT token. Let's say there are like 5 NFT tokens, right? This map goes over each one of them. Let's say it's on the first one. It takes the token ID of the first one, gets the token URI for that, right? Now this token URI, we take this URL, we make an Axios request for that token URI, get all of the details for that in the metadata, and then create an object called item with all of the details from both places combined, right? So we basically get the token ID, seller, owner, and image, like not even, sorry, token ID, seller, and owner from the object that's returned by the smart contract, and then we get the image, name, description from the metadata, right? So we basically populated this whole item object that will go on to be used later in the marketplace to display the NFTs, right? So we pull all of this data and then we go ahead and display it. Very importantly, one last thing, if you like, you must be wondering what this data fetched item is, right? So data is basically the data that we have fetched, and you see that we update it, right? So we call the update data function to update this state and add the items object to it, which is the object with all of these NFT data, right? But the data fetched is just to make sure that we fetch the data once and then we don't do it again and again. Because otherwise, if you don't do it, then React works in a way that this function will be called again and again and again infinite number of times. So we put like a condition, if not data fetched. Basically, if the data is not fetched, then you call the get all NFT function. But if it is fetched once, you just update fetched to true, in which case this will not be called again. Do you see what I'm saying? Uh, Basically, the point is that we do not want this function to repeat again and again, but the way it is put and the place it is in right now, it will be called again and again. So we have built in this synthetic mechanism to make sure that it's not called again and again. Make sense? So at the end of it, we'll have data populated, and this should be running in the marketplace. Now, if we go to the website, on the marketplace, yep, I think our dog NFTs are. Oh no, sorry, I actually not. I think if you go to this marketplace, it should be broken. Yeah, so it's a slightly broken UI. Basically, for null NFTs, it's showing like a slightly weird UI. But point is that there are no NFTs right now here to display, and now we've been able to successfully integrate in the marketplace. Now it's time to go ahead and list an NFT, right? So let's do our dog number one. Like, you're not seeing the dog NFTs here, by the way, because we changed the smart contract. We redeployed it, and so there's a new smart contract that our code is tracking, right? It's not the same one. All right, something super quick that I messed up when we were writing the sell NFT code was like a tilde over here instead of a not. So basically, you want to do a not price to check that the price is not null. And if it's a tilde, so it would return an error, right? So once we fix that, we should be good to test our marketplace. And so let's go ahead, let's test it. All right. As you can see, we're in the state where our marketplace main page is empty. The list NFT is form is there and the profile is also empty, right? So let's try to upload a dog picture now. So like dog number one, dog test, give it like a 0.02 ETH, and then add like a photo, right? Now the photo is added, we go ahead and list NFT. It instead takes us to Metamask, which is awesome news, which means it's working. Confirm. It will take its own sweet time, like I said. So after which we expect the alert to come up, okay, that your data was successfully uploaded, NFT was uploaded, but it will take its own time and we should not mess up with it. But you can see like it's connected, it shows connected. Even if we reload, it will all work fine. So let's just wait for the message. And meanwhile, in the interest of this tutorial not becoming super long, we're going to just add the code for the rest of the components, right? So we've really explained in depth how the sell NFT code works. Also talked about the navbar code, also added the marketplace code. There's like 2 3 components more, but we'll just very quickly go ahead, copy paste code, and you can take that code from the finished GitHub repository as well, which is linked in the YouTube description, or you can also look at the written tutorial to take that particular code snippet. But the idea is that you have the code and we've explained most of the important parts, so you should be very good now in terms of integrating it with the other components, right? Do not want to make this a super long tutorial, but if you have a question, if you hit a roadblock, well, why not just tag me or any of the DevRels at Alchemy in our Discord? We'll just be very happy to help. Cool. We see that your NFT was successfully listed. Congrats. If you go okay, hopefully we see. Okay. Awesome. All right. We were able to upload an NFT to our marketplace. We were able to make the upload work where we were able to list the NFT. We were able to make the marketplace work, and we were able to make the navbar work. How awesome is that? Congratulations on making all of this work. Let's just add the remaining code to the rest of the front-end components, and I guess we're good to go, right? Great. So towards the end of this tutorial, we're done with most of the components, and we just need to update the code for 2 more components because everything else is sorted, and our upload of NFTs works. So the only 2 components left are NFT page and profile, right? Profile is where we are showing our own NFTs, so my NFTs and some aggregated data on top of it. And then NFT page is the page for a particular NFT where you fetch data. So that's one thing that you do. And then another thing is the buy this NFT button, right? So I'm going to, like I said, very quickly, just copy paste code because you can access this code from the completed code repository on GitHub, and that should solve all of our things. Awesome. So that's the profile.js code. And let's also paste the NFT page.js code. Great. So we have all of the components complete now. We have the marketplace.json complete, Pinata.js is complete, our end file is set up, our Hardhat config is set up, and our smart contract is written. Also, our deploy.js script is set up. So at this point, we have finished adding all of our code to the repository, and hopefully a lot of this works. You've gone through multiple things throughout this tutorial, and now let's do a final test to see if the tutorial works correctly and how we can extend it. Great. So this is the tutorial so far. You have list my NFT, your profile, your navbar. You see that, okay, we have one number of NFTs, right? So let's upload a few more dog NFTs. Second, and let's set a price to them, right? So let's do post us, just tweet out Alchemy platform, tell us which is the dog that you like the most, or just tweet my Twitter and I'll be happy to respond to all of the funny pictures that you could post of dogs. That'll be awesome. Great. So list NFT again. It opens my MetaMask. It's important that you have Goerli ETH in your MetaMask for all of these transactions, because if you have not requested Goerli ETH from the Faucet, it will be really hard for you to get these transactions through. I mean, it's literally impossible, not really hard. Now it just takes its usual time and then it should come up, right? Meanwhile, as it happens, we can probably talk about what else do we want to do. So once these NFTs are uploaded, we can probably just switch the account once and try to buy one of these NFTs and see if they come up in the profile of the second account. And if that happens, then it works end to end basically, right? So it's successful. All right. It takes a while to load because IPFS is a little buggy and you cannot really rely on it. I mean, there are dedicated IPFS gateways through which you can search stuff, but for now, we're using the free account. You'll be using the free account, which is why expect it to be a little buggy and a little lag in actually showing up images. Awesome. So we see that, okay, our list my NFT has been working properly because it uploads NFTs to the marketplace. Our both dog images have been uploaded. Actually, it looks like the same dog. It's pretty nice. This works as well. Marketplace page works. Our profile page works because it shows us the values of both of those NFTs combined, the number of NFTs and the current address logged in. The nav bar works properly because all of the things are being shown correctly. And if you click on the marketplace page, just go to click on any one of these dog photos, you'll be able to see that, okay, this page is also working correctly, right? So we can see that the NFT page is working correctly. It shows you are the owner of this NFT. We can look at it for the other dog image as well. Awesome. So the metadata is coming correctly and we are seeing the right messages. Let's do this one last thing where we switch the account and try to buy this NFT from another account. And if that works, well, we are sorted. Okay, so I've switched to account 2. It asked me to connect. I connected. It reloads the page just like we expected it to. And let me try to buy this NFT, right? If you go look at my profile, there is nothing here in this account. So if I'm logged in with this second account, I will not see any NFTs. But I should be able to buy an NFT. And if I successfully buy it, then it should show up here in this particular page, right? So let me try to buy this one NFT, right? So we click on buy NFT. Awesome. It triggers my MetaMask, which means at least the first step is going right, and I should be able to buy the NFT. It's around 0.02 plus gas fee, so it's whatever, 0.0203 ETH price that I'm going to pay. I'm super excited for this. If this gets transferred, you know what? We're probably done building the NFT marketplace. Yeah. It takes its own sweet time again because Goerli is just generally slow with block time sometimes. And there are a couple of really interesting things that I think you guys can do to extend the NFT marketplace that will go a long way. So it says you've successfully bought the NFT. Let's see. So if I had successfully bought the NFT, then what we would have seen is the dog in our profile. And that's exciting because the dog has showed up in our profile, which means we bought it. And if I click on it, it says you are the owner of this NFT, right? So from seeing the buy this NFT button to you are the owner of this NFT is now owned by us. We've successfully created a marketplace where you can go upload an NFT and it shows up in the marketplace, it shows up in a profile page, there are stats that you can see, and then we've also added steps to let others buy your NFT, right? We've successfully integrated wallet login, and that means we've built pretty much a basic marketplace end to end, starting from login to uploading of NFTs to buying, right? And that's awesome. I mean, if you've been able to do this tutorial so far, you're one of the very few devs who have gotten to building an NFT marketplace. You've written one of the more complex smart contracts, and I congratulate you on spending all this energy in a very positive pursuit. With that, you've been able to build and deploy an NFT marketplace to your local systems. You have built several features, including wallet integrations, including display of NFTs, including fetching functions from smart contracts, and a whole host of things. You've even learned how to upload data to IPFS via Pinata, which is, I think, a big win. Now, in terms of next steps, I think a couple of things that you can do is go ahead and deploy it, right? Use, I don't know, use Heroku, use Firebase, any of the deployment tools. Go ahead and deploy your NFT marketplace. I would love to see the version of the NFT marketplace that you build, right? I mean, this one's a dog NFT marketplace. I don't know if you build a cat NFT marketplace or your own vacation photos or anything like that. If you have cool ideas, just deploy your marketplace, show us your photos or show us whatever you want to add and tag Alchemy platform. Like if you end up sharing on Twitter, please make sure you tag ANKG404 or Alchemy platform. We would love to see what you've built, right? I mean, day on day, the biggest happiness that we get is to see our devs doing really well and learning from our tutorials. So if you share that with us, I think that would make my day. And then a couple of extensions that you could try out, just super interesting things to make this NFT marketplace even more rich. One, try to add the Alchemy NFT APIs. So we have the get NFTs and get NFTs for collection endpoints that should give you, given a contract address or an owner address, it should give you a list of all of the NFTs. If you can integrate that in the profile page in the marketplace, that's a very big positive. That'll be amazing. Another extension would be to add the feature to add pre-existing NFTs. So if my wallet has NFTs from, let's say, OpenSea or any other marketplace, I should be able to list them on this marketplace, right? So that's a very good feature in terms of cross compatibility where all the marketplaces can work together. And then one last feature that you could maybe try adding, and this will take some smart contract mastery as well, is to add an approval function, right? So basically separate out upload and approval, right? So if any NFT is uploaded, it's not listed by default. You have to probably click on a button or hit a checkbox to make sure that it is listed and now people can go buy it, right? So I think these three are very good extensions that you can try to build it, take it as a project, right? And if you end up doing that, well, brownie points to you. I'm sure the Road to Web3 community, Vito, Albert, all of us will definitely appreciate the efforts that you've put in. It was awesome building this tutorial with you. It was a lot of effort, and you and I have both toiled through. Looking forward to listening all of your feedback. If you have any suggestions, comments, drop them in Discord or in our Telegram chat with Road to Web3. If you have any questions, if something is unclear, please feel free to let me know. I'm pretty sure this tutorial is not perfect and there is a lot of scope to improve. We are always looking for feedback and always looking to learn. Please keep us posted with whatever you're building and happy building. All right. Waiting for the submissions at the end of the week. See you guys. Bye.